a wheel 25 centimeter in radius turning at 120 revolution per minute increases its frequency to 660 revolution per minute in 9 seconds. Find the tangential acceleration at a point on its rim. Now, don't forget, this is another beautiful one, but it's very simple. First of all, let's bring out our parameters. Here we're talking about a wheel, a wheel with this very radius. What's the radius of the wheel? The radius of the wheel is 25 centimeters. We're going to move this to meters. How do we do that? We divide it by 100. 100 centimeters is 1 meter. So 25 divided by 100 gives us 0.25 meter. That's the radius we have. Now, turning at 120 revolution per minute. This 120 revolution per minute is the initial angular speed. So what's that going to be then? That'll be initial angular speed, which is 120 revolution rev per minute. We move that to rad per second. How do we do that? 1 rev is 2 pi rad. So times this by 2 pi. 60 seconds is 1 minute divided by 60. You're going to end up having, 4 pi rad per second. So just 120 times 2 pi divided by 60. So 4 pi rad per second. So the final, speed increases to 660 revolution per minute. So that's going to be the same thing, 660 rev per minute multiplied by 2 pi divided by 60. Then we're going to end up having 22 pi rad per second. So we have this. So now we are asked, everything took place in 9 seconds. So we are asked to get the tangential acceleration. Now, what's the formula for tangential acceleration? Don't forget that tangential acceleration is written as what we call the linear acceleration. We derived the formula for that already. Tangential acceleration is equals to angular acceleration times radius. That's why if you have not seen the previous lessons on the derivations derivations of all the formulas on circular motion, there's no way you understand what we're taking 100%. So angular acceleration, tangential acceleration, I beg your pardon, is angular acceleration or centripetal acceleration times radius. So now, what's the angular acceleration? We've done that already in our previous class. We used this to get the angular acceleration. When you put in those values, you're going to get angular acceleration. Angular acceleration is equals to 2 pi rad per second squared. Just put in the value. The final 22 pi, 4 pi rad initial angular acceleration times 9 seconds. You do that, fix everything into this place, you get to this. So now the side time we got our linear acceleration, angular acceleration, 2 pi rad per second squared times radius. What's the radius? Radius is 0.25. 0.25 meters. So you're going to multiply. So 2 times 0.25 will give us, that'll give us 0.5 pi